Welcome back, everyone. This is Pamela, and I'll be doing the second STATA demo for this week. So we have two objectives for this demo. First is to calculate the crude incidence rate ratio of CHD for smokers compared to non-smokers in STATA. The second objective is to calculate the age-adjusted incidence rate ratio of CHD for smokers compared to non-smokers in STATA. Now remember, back in weeks 3 and 4, we talked about why, for an outcome like CHD, we want to use incident rate ratios and incidence rates instead of risks or risk ratios. The issue with an outcome like CHD is that we might not have complete follow-up for everyone. They may have dropped out of the study or suffered a competing risk before we could observe whether or not they developed CHD. Because of this, we're just going to use person time. We have the amount of time that someone was followed for CHD. And we'll use the person time and the number of CHD cases to calculate incidence rate ratios. So now let's go to STATA and calculate the crude incidence rate ratio of CHD for smokers compared to non-smokers. So now that we're in STATA, just make sure that you have the Framingham Heart Study data open, the same data set that we've been using throughout the course. We're going to use similar commands that we did in weeks 3 and 4. So we're going to go up to Statistics, go down to Epidemiology and Related, and go over to Tables for Epidemiologists, and then select Incidence Rate Ratio. A new window pops up. And first we're asked for our case variable. And our case variable here is any CHD. That's our outcome. And our exposed variable is smoking status at baseline, whether or not you were a current smoker. And that variable is called CUR-SMOKE1. So just scroll down and select CUR-SMOKE1. Then also we want our person time variable. This is the amount of time that someone was followed for the development of CHD. And that variable is called time CHD. So just select that from the drop-down list. And once you've done that, just hit OK. So now we have this table full of results. And I'm actually just going to go back to PowerPoint where I've copied these results from STATA to PowerPoint just to make it a little easier for you guys to read the output. So let's go back to PowerPoint now. So now that we're back in PowerPoint, I have the same results from STATA along with the STATA commands at the top of the screen if you're more comfortable using STATA commands instead of the drop-down menus that I showed. Now this top panel here shows the same information that we've used earlier. It has the number of exposed, the number unexposed, and it has the number of cases that developed in each group, and also the amount of person time in each group. Okay? What we're really interested in, though, is knowing the incidence rate ratio. And we can find that in the bottom panel down here. And we see that the incidence rate ratio is on the second line. The incidence rate ratio in this study is 1.03. That means that people who smoke have 1.03 times the rate of developing CHD compared to non-smokers. So we see a slightly higher risk of CHD among the smokers compared to the non-smokers. Not a huge increase in the rate of developing disease, but there still is a small increase. However, Fran brought up in his lecture that this number might not actually be the true effect of smoking on the rate of CHD development, because there could be confounding by age. So confounding by age could happen if age is associated with smoking status. So for example, if younger people are more likely to smoke, then there would be an association between age and smoking status. We also need to see if there's an association between age and our outcome, which is CHD, even among those who do not smoke. So among the non-smokers, is age related to CHD? And yes, we know that even among non-smokers, people who are older have a greater rate of CHD development than people who are younger. So based on this theory that we've talked through, it does seem reasonable that there could be confounding by age in our study. So now, let's calculate age-adjusted incidence rate ratios of CHD. Now, since age is a continuous variable, we're actually going to divide it up into 4 categories, similar to how Fran did in his lecture, and similar to how we did in the previous STATA demo. So I'm going to create a new variable called age for cat. And then I'm going to replace that variable with values for someone being less than 40, 40 to 50, 50 to 60, and 60 or older. And I'll use the drop-down menu or the command line to calculate the age-adjusted incidence rate ratio of CHD. So now let's just go back to STATA and we'll type in the commands that I have here on the screen and we'll see whether or not there was confounding by age in our study. So now that we're back in STATA, the first thing that we want to do is create our new variable called age for cat. Now I want to assign values of age for cat based on someone's age at baseline. So I'm going to say that age for cat equals 0 if age 1, this is age at baseline, is less than 40. Next, I'm going to do my second category of age for people who are between the ages of 40 and 50. So if age 1 is greater than 40 and age 1 is less than or equal to 50. Now I'm going to do the same thing for my next age category. So age cat equals 2 if age 1 is greater than 50 and age 1 is less than or equal to 60. And then finally, we're going to create a category for those over the age of 60. So if age 1 is greater than 60 and also less than missing. Okay, so now that we have those new categories created, we're going to go up to our drop-down menu to calculate an incidence rate ratio that's adjusted for age. So go to Statistics, go down to Epidemiology and Related, and go over to Tables for Epidemiologists, and then select Incidence Rate Ratio. If we do that, we're going to use our case variable, which is any CHD, our exposed variable, which is cur_smoke1, so whether or not you are a smoker at baseline, and our person time variable, which is time CHD. However, we need to do one more step in order to get age-adjusted incidence rate ratios. This other step is just click on the Options tab, and then click on the box next to Stratify on Variable. Now go to the drop-down menu and just scroll down until you get to that new variable that we created called age for cat, and click on that. You'll notice too that right below there's a box that says Within Stratum Weights, and the button right next to Use Mantel-Hansel should be selected. And that's just telling STATA that we want to use the Mantel-Hansel formula to adjust for age in this study. So once you have that all selected, just hit OK. And you can see that this panel of output shows on your screen. And we're actually just going to go back to PowerPoint again, just because it's a little bit easier to read in the recordings. So now we're back in PowerPoint looking at the age-adjusted incidence rate ratio of CHD. You can see that I have the STATA commands up at the top if you're more comfortable using the commands than using the drop-down menu. Now this window that outputted shows us the incidence rate ratios in each different age category. So for people in the first age category, those are those less than 40, we can see that the incidence rate ratio is 1.27. Then we can also see the incidence rate ratios for the other age categories, comparing smokers to non-smokers. They kind of bounce around a little bit, so there could potentially be some different effects in the different age categories. If we look at the bottom, there's the crude incidence rate ratio, which is right here, and that's 1.03, which is exactly the same as what we calculated earlier. Right below the crude, we can see the Mantle-Hansel combined, that's MH combined effect estimate. And this is the incidence rate ratio of CHD adjusted for age. And this age-adjusted incidence rate ratio is right there, and it's 1.28. This means that after adjusting for age, people who are smokers have 1.28 times the rate of developing CHD compared to people who are non-smokers. Now you can see that there's a pretty big difference in the incidence rate ratios between the crude incidence rate ratio, which is 1.03, and the Mantle-Hansel age-adjusted rate ratio, which is 1.28. So this does support that there probably was some confounding by age, because after we adjusted for age, we're getting an effect estimate that is closer to the truth. So that's it for today's demo. Hopefully you guys enjoyed learning how to age adjust your incidence rate ratios of CHD. Thanks.